Distinguish between intermolecular and intramolecular forces. By examining the diagram, the circled areas outline interactions occurring between two different, separate molecules, the nitrogenous bases adenine and thymine/uracil, rather than within a single molecule. This means the correct answer must be an intermolecular force, IMF, rather than a covalent chemical bond. Analyze the specific atoms participating in the circled interactions. Top circled area shows a hydrogen atom covalently bonded to a nitrogen atom, NH, on the left molecule interacting across space with a highly electronegative carbonyl oxygen atom, C=O, on the right molecule. Bottom circled area shows a ring nitrogen atom, N, on the left molecule interacting across space with a hydrogen atom covalently bonded to a nitrogen atom, NH, on the right molecule. Recall the definition and requirements of hydrogen bonding. A hydrogen bond is a particularly strong, highly directional electrostatic intermolecular attraction. It occurs when a hydrogen atom is covalently bonded to a highly electronegative atom, specifically N, O, or F, causing the hydrogen to carry a significant partial positive charge, delta to the power plus. This electron-deficient hydrogen is then strongly attracted to a lone pair of electrons on a highly electronegative atom, N, O, or F, of an adjacent molecule. Evaluate the circled interactions against these criteria. The top interaction involves NH times SO, which fits the criteria perfectly. The bottom interaction involves N times SHN, which also fits the criteria perfectly. Determine the strongest interaction. While London dispersion forces are also present, hydrogen bonds are the strongest type of intermolecular interaction occurring between these complementary polar regions of the two molecules, making option C the correct answer. The correct answer is option C, hydrogen bond.